Hello guys, welcome back to Chemistry Study Group. So in this video, we are going to continue with electronic configuration. In our previous video on electronic configuration, we define atomic orbital, and we also tell us that electronic configuration is a way of arranging electrons in the orbital of the subshell. Alright, so in this video, we'll be explaining the ground state electronic configuration, excited state electronic configuration, and the condensed electronic configuration way of writing. Alright, so I will start with the ground state and the condensed form because they are closely related. This ground state and condensed form, they are what the state, the lowest energy arrangement of electrons in an atom. The lowest state electron arrangement in an atom. So we are going to start with them. Alright. Now they follow strictly the Albert principle first, right? Then Pauli's exclusion and the Hund's rule like that. Alright. So let me give us practical example. Alright. So let's say the ground state. Now, the ground state, don't forget it, they are the normal way of writing electronic configuration, right? They are the full way of writing electronic configuration, just as we have here, okay? So I decide to stop here, so it can continue like that. So this is the ground state, the normal way. Let's say, for instance, I want to write electronic configuration of carbon, which is 6. So we are going to see what 1s. Don't forget, we have done all this before. S orbital, you see, I don't need to be explaining all this once again. So 1s can carry 2, 2s can carry 2, then it still remains 2 to be distributed. Then we'll go to what? 2p, and 2p can carry 6. But because it's only 2 that is remaining to be distributed, we'll put the 2. Okay, so this is the ground state configuration of carbon. All right, so let's do the condensed form. The condensed form. Now, condensed form is a shorthand way. Okay, it's just a shorthand way of writing the full ground state configuration. So we represent them with what? The noble gases. All right, so the noble gas here we have what? We have helium 2, we have neon 10, argon 18, krypton, xenon, and radon. So we are going to be using these noble gases as shorthand in writing the condensed form. Take for instance now, and don't forget, in writing it, we are going to cut from the last S. From the last S, not from the first S, from the last S. This is what I'm talking about. We want to write the condensed state of carbon now, right? So carbon is 6. So the last S from here is what? 2s. So this is the last S. So we'll cut from here. Now after cutting, we look at how many electrons we have. We have only 2 electrons. So we'll come to the noble gas. We have 2 as what? Helium. So helium, will bring the helium down. We'll bring helium, right? So this is the 2. Then we'll write the remaining one. 2s2, 2p2. All right, so this is what the condensed form. Let's take another example. Let's say sodium. Sodium 11 is 1s2, 2s2, 2p6, and what? This is 10, it still remain 1, and 3s1. Okay, 3s1. We are cutting from the last s, so this is the last s. The last s here is 2s2, so we'll cut from there. This is the last s. Now we'll cut from the last s. All right, so what are we left with? 1, 2, 3. This is 10 electrons. So we'll go back to the noble gases. Which one have 10 electrons? Is neon. So we'll bring down neon. So for sodium now, we bring down neon, Ne, and we write the remaining 3s1. Are we together now? Let's give another example. Let's say we want to give example for calcium. Calcium is number 20. So we have what? 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. So this is 10, this is 10, this is 20, right? So the condensed form now will be what? We'll check the last S. Where is the last S? The last S is 4s. So cut from that last S. Okay, cut from that last S. So which one is, how many electrons do we have that we cut from? 1, 2, that is 4, that is 18. So we cut from 18. We'll now check the noble gas. Which one is 18? 18 is argon. Argon. So we'll bring the argon now. We'll bring the argon and write the last 4s2. Okay, so this is what? Condensed form of writing electronic configuration, and this is the ground state of writing electronic configuration. But then the excited the excited form, okay, so the excited form actually happen when our atoms receive energy. Okay, so they are excited from lower energy level to a higher energy level, right? So the only difference between excited state and ground state is that in ground state we strictly follow the alpha principle first, but in excited state, because they jump, atoms jump from, electrons jump from lower energy level to a higher energy level, they don't really obey that alpha principle first, even though they still do, but they don't really prioritize it, because they can move at any time, they can rearrange at any time, okay, as soon as they receive energy. Now let's say we want to write the excited form of carbon now. So carbon 6, we want to write the excited form, right, of carbon, electronic configuration, the excited electronic configuration of carbon. That's what we want to write. Now, if you look at this 1s2, 2s2, 2p2, right? The lower energy level before the higher energy level is 2s2 before 2p2. Now, it will be 1s2 instead of 2p2 now, 2p, instead of 2s2, instead of 2s2 now, one electron will jump from this lower energy level to a higher energy level, all right? So that it will be what, 2s1, then the electron that jump will enter the higher energy level, which is 2p. It will now be 2p3. Are we together now? So the electron jump from lower energy level to what, a higher energy level. Look at for sodium now. Sodium 11. Normally, we are supposed to have 1s2, 2s2, 2p6, right? Right, then 3s1. Okay, now in this 3s1 now, eh, this is where we stop, right, in the ground state electronic configuration of sodium. Now look at what will happen. 1s2, 2s2, 2p6. Now we are supposed to have what, 3s1, but because this 3s is lower energy level, it will jump from this 3s1 to what, it will jump from 3s1 to what, 3p. So it will not be 3s1, it will not be what, 3p1. So it has jumped this, the electron have jumped from this 3s to the next orbital. Okay, so we now have what, 3p1. Look at for calcium now. Calcium 20. We are supposed to have 1s2 like this. So now by the time we reach this orbital now, this last s orbital, it will jump from this lower energy. S is lower than p, p is higher than s, so it will jump from this lower energy level to the next orbital. Okay, so that we now have 1s2, 2s2, 2p6, 3s2, 3p6, right? So 3p6, we are supposed to have 4s, right? 4s what? We are supposed to have 4s2. It will now be 4s1. Okay, 4s1. It will now jump towards 3d1. It will now jump toward 3d1. Okay, so let me rewrite this part. It will be 3p6, 4s1, and 3d1. Normally it's supposed to end with 4s2, but the electron jump from this s orbital towards d orbital, from lower energy level to higher energy level. All right, and this particularly happen when atoms receive energy, right? So they emit, they are excited. All right, so these are the difference between the ground state electronic configuration, the condensed way of writing electronic configuration, and the excited form of writing electronic configuration. If you need more clarification, you can go ahead and ask your question in the comment section. We may have time to respond to every one of them. Okay, and if this video makes sense to you, please don't forget to like, share, and follow us for more. God bless you.